Okay, here we go. I call this Trigonometry in Motion. Now, what got me started on this? Here's a little TFT display with an analog clock. And I was going to say what got me started on this, I have no idea how I ended up here. It always, one thing leads to another. This is a Arduino Nano clone down there in the wires. Over here, this is a level shifter. It just shifts the 5 volts to 3 volts, which, because the Arduino, the Nano puts out 5 volts and the logic on the TFT is 3 volts. And there we go, we got in focus again. So we have to use a little level shifter. That's great. Buy a $2 clock and have to buy a $2 level shifter. Doubles the price. Anyway, this here is a real-time clock. Okay. You can see on the back there. Why am I having troubles focusing today? There we go. You see on the back the actual circuitry for the clock. The little silver cylinder there is a crystal oscillator that gives it a really high, resolution. It keeps the time very accurately. This is a BAB, a big-ass battery, that whenever I unplug it, it keeps the time. I don't have to reset it every time. When I turn it off, it comes back. What happened today, though, I had to reset the clock for daylight savings time. I was looking at some algorithms to change that. I don't know how enthusiastic I am about trying to do that or messing with that, maybe in the future. Anyway, the point being, I got the little real-time clock, got a little display, and was spitting out a digital display and wanted an analog display. And thinking about it, I thought, well, some smart guy was bound to have written the program before, so as with all programming, let's see, here it is right here. Program, the guy wrote it. And I had to do some modification. I'm using a different library than he is. Mine has color, his didn't for some reason. Well, it was his library. But it was easy to modify the code. And what this function here is drawing the seconds, the second hand ticking around. And it puts in the time. It gets the time from the clock. It sends the seconds, 1 through 60, and it takes that and it multiplies it by 6. This gives us 360 degrees, 60 seconds, 360 degrees. So we move, every second we move 6 degrees. And I'll show you this, why we're adding 270 here in a minute. This is interesting. This is 0.0175, which is pi divided by 180, which converts our value, which is in degrees, converts it into radians. And we have cosine, which gives us our x value, sine, which gives us our y value. And multiplying, these multipliers here just offset the, what am I trying to say? Just offsets it a little bit. I've got down here you can see this is a starting point and this is the ending point of drawing the line. Back to this, I couldn't help making a little chart here. I thought it was really interesting since I had just gone through a trigonometry class recently. They didn't like my 1983 degrees, so I had to go through and get a new one. I'm going through and getting a new one. That's another story. So this is the function. This is cosine over here, sine on this side, and I am just multiplying it by 6 to get degrees, and only went through 180 degrees here. But you can see it starts over here at 1, 0 and goes all the way around. 90 degrees, 180 degrees, and everybody's familiar with the unit circle, of course. We got a negative 1 over here for the x value at 0. Now, what's interesting though is multiplying it or adding 270 degrees to it. You see we go here 90, 180, and all the way down here at the bottom 270 degrees. So we shift our whole circle around 270 degrees, and we start down here counting around. Well, that's just wonderful. It's still going backwards and it's still going upside down. So whenever I put the numbers displaying on here so I could watch what it was doing, I finally realized, come on, get back into focus. I finally realized what it's doing. It flips the whole thing upside down. Actually, this number up here, this top corner is 0, 0, and down here, I forgot what this is, 128 by 64, I think. This is so it starts with 0, 0 up here, and here in the middle is something near 30, 30 or something like that. That's a different story there. I put the numbers on here so I could watch it, and it flips the whole thing upside down. So really, it goes this way after it's upside down. This is actually -1 up here instead of it being 1 like this here. You can see it's a -1 down there on the bottom. So it flips the whole thing upside down for our little display. So point being, I was pretty excited whenever I saw that the guy was using sine and cosine to calculate these XY values. And I guess I hope somebody else is thrilled about that too. Thanks.